Alright, welcome to the first part of 1.2 Photochemical Smog. In this video, we will be focusing on both of these boxes. First one being nitrogen oxides are formed in high temperature engines and furnaces. You need to be able to write equations for the formation of nitrogen oxides, NO and NO2. Secondly, nitrogen oxides and ozone are pollutants in the troposphere. Troposphere is where we are, where we stand, the atmosphere around us, that are associated with photochemical smog. You need to be able to describe and write equations showing the role of nitrogen oxides in the formation of ozone in the troposphere, and describe the harmful effects of nitrogen oxides and ozone in the troposphere, both of them. And finally, describe and write equations showing how catalytic converters reduce the quantities of nitrogen oxides generated by motor vehicles. We'll probably do the last dot point in a second video. Well, let's look at the first part. So, formation of nitrogen oxide. Photochemical smog, by definition, I'll put that back, there you go, is that haze in the atmosphere accompanied by high levels of ozone and nitrogen oxides, so combination of both, caused by the action of sunlight on pollutants. So there's two stages. You have got primary pollutants, and that gets converted to secondary pollutants by the sunlight. That's what photochemical chemical reaction caused by light occurs and then forms smog if you concentrate it. At high temperature, engines and furnaces supply energy to break bonds in nitrogen and N2, allowing it to react O2. Nitrogen itself is very stable molecule because of a triple bond between nitrogen atoms. But if you provide enough energy, then they will break. And once it breaks, it wants to grab onto something that's around them. In this case, we will be looking at oxygen being bonded to nitrogen. So that's the first equation, first stage. So nitrogen gas and oxygen with a lot of heat, which is not written here, but a lot of heat is required. Could be lightning, but car engines where we are working in as a context, which makes two molecules of NO. Nitric oxide, I believe. Nitric oxide is NO. And when you have nitric oxide, NO, and because this is reactive as well, it's not very stable, wants to react with oxygen again, O2 gas, which makes two lots of NO2 gas. So two equations can go into that slide. NO2 is nitrogen dioxide. These are both oxide of nitrogen. And if you have that, that itself is a pollutant. Harmful effects that they're associated with. Firstly, it reduces the rate of photosynthesis in plants. Secondly, it causes coughing, wheezing, constriction or irritation in respiratory system. So anything to do with respiratory system. And also, if you remember from last year, nitrogen dioxide, when it bonds with water, it becomes nitric acid. Therefore, third point is forms acid rain. They are the harmful effects of oxides of nitrogen. Motor vehicles, they release the primary pollutants, which are these two guys. And photochemical reactions can occur on them if there was a lot of them, and also sunlight was there and it's intense and the condition was still, as in no movement of molecules were there. If there was wind, well, they would probably go elsewhere. But if those conditions are present, then highly likely that they would be forming ozone. All right, so ozone is secondary pollutant, one of them, and if it concentrates, we call that as photochemical smog. All right, this diagram here shows the formation of ozone by nitrogen oxide. So you can see that there's blue sort of smoke coming out from cars and factories. They are the primary pollutants. And if you follow the arrow going this way, yeah, you can see the reaction happening caused by the sunlight. It becomes photochemical oxidants and it concentrates into photochemical smog. And the person is crying there, having some negative effects on it. On him or her. All right. Nitrogen oxides lead to the formation of ozone. So here's where we write the equation. There are actually two steps to it. So nitrogen dioxide gas, if it's exposed to UV or intense sunlight, it would break down to nitric oxide, NO gas, plus O2. Oh, sorry, not O2. This is just O. Oxygen atom on its own with just one electron floating around. Depending on which textbook you read, you might actually see a dot written like that. That dot shows there's one electron that's not used for bonding at all. So it's very, very, very reactive. That electron wants to bond with, make a bond with something. And it does that. If you have this radical oxygen, so oxygen on its own, when it grabs onto oxygen molecule, O2, it just makes ozone, O3. So that's the formation of ozone. And you can see that the NO2 is a big part of ozone formation. You can also see there is a diagram there showing structure of ozone. It's not triangle, it just forms that bent shape because triangle is a bit too hard as an angle for oxygens to achieve. So yeah, ozone is a bent shape and it keeps switching the structure. So there's a bit of stability, but still very reactive in terms of oxidizing something. It wants to give that oxygen away to oxidize. Ozone in the lower atmosphere, so troposphere, yeah, has harmful effects. There are four dot points there, but it's very similar to what we said before to oxides of nitrogens. First one is reduces the rate of photosynthesis in plants. You can see in that there in the picture there that leaves are having brown spots. So that somehow it lost the chlorophyll or cell wall being broken. Probably ozone can do that by oxidation action. And the second one is causes coughing, wheezing, constriction, and irritation in respiratory system. So that's the same as harmful effects of nitrogen oxide. Third one, breaks down the cross links in rubber and deteriorates them. Here's a rubber band. As you can see, it can stretch. That's because so many of these carbon bonds are connected with what's called cross links, like so. If they can move around, it shows the stretchability. But those cross links can break. So you will have smaller chunks of rubber molecules. So yeah, you would observe that rubber losing the elasticity and just breaks down when you try to pull. And also the last point that I want to mention is deteriorates plastics. So plastics have cross links between as well for it to have some rigidity. And if it loses it, it just becomes little particles. So you might know some plastic that's left on the ground for a long time, it starts showing some powdery texture to it. That's what the UV ray and ozone potentially be doing. But UV ray itself can do that too. With catalytic converters, we'll spend some time on in the next video. So see you then.